Lesson 7-6, factoring polynomials, and we're looking at factoring standard form polynomials with a coefficient other than 1. So in example A, we have 5x squared plus 15x plus 10. One of the things that I want you to note right off the bat is that we have a 5, a 15, and a 10. So I'm going to notice something about that. I'm going to notice that this shares a common factor, or a GCF, of 5. So what I'm going to do is, the very first thing I'm going to do is I'm going to factor out a 5 out of this entire standard form polynomial. When I do that, I'm left with x squared plus 3x plus 2. And when I do that, I'm going to notice that I've got a really nice standard form polynomial that I could factor. And I could use one or two methods to factor. I could use my rectangle method that gets coupled with the diamond method. Or in this case, I'm actually going to use the factor method. And the reason why I chose the factor method is, one, I've got very simple numbers inside my polynomial. I have 3x and 2. And I'm also going to notice that I added 3x and I'm adding 2. Which means that when I go to factor, I'm looking for two factors that sum to 3, but when multiplied give me a value of 2. Well, I can only think of two factors of 2, and that is 2 and 1. And 2 times 1 is 2, and 2 plus 1 is 3. Therefore, I have x plus 2 times x plus 1. So notice that I pulled the 5 out. That's important. I need to put that GCF in front of my factors of x plus 2 and x plus 1. And all of that is indeed equal to 5x squared plus 15x plus 10. And I can verify that by first distributing, or first using FOIL and then distributing the 5. However you do it, we would end up with 5x squared plus 15x plus 10. If you are somebody that enjoys using the box method, again, I would have done the exact same thing. I would have put x squared right here. I would have put my last term right there. I would have put the 3x beneath. I would have put 2x squared right up here, because I would have multiplied 2 and x squared together. And I would have looked for two values, 2x and 1x. Oops, that's an x. That would have summed together. And then I would have placed them accordingly inside. I would have put 2x here, and I put 1x here, and then 2 and x and 1. So plus 2. So I would have gotten the exact same answer. So again, paying close attention to my original polynomial, noticing that I could pull out a GCF. So now let's look at example B. Notice in example B, again, I've got 4x squared plus 13x plus 3. I'm going to take a look, and now I've got a coefficient of 4, a coefficient of 13, and a constant term of 3. I'm looking for GCF. There's no common factor other than 1 that those three terms share. So I'm not going to be able to factor anything out of this polynomial. So my go-to method in this case is going to be my rectangle. And again, I do want to note that I tend to always put my x squared term in the lower left-hand corner. I've seen a number of examples in textbooks and on videos that show it up in the upper left-hand corner. You could use whatever method you want. I just find this to be very easy for me to follow. So I tend to do the same thing over and over again. So again, I'm going to place 4x squared in the lower left-hand corner. And now I'm going to place my last term in the upper right-hand corner. And I'm now going to multiply these two values together. And when I do that, I'm going to get my top diamond value of 12x squared. So now I have to come up with my two factors right there. And what do they need to sum to? Well, I'm going to notice they need to sum to 13x. So now, again, I'm looking for two numbers that when I sum them together give me 13x, but when I multiply them together give me positive 12x squared. Well, I can come over here and make a list of factors of 12, which I know are 12 and 1, and 6 and 2, and 3 and 4. And I'm looking to sum to 13. Well, there it is right here. I've got 12 and 1. So I'm going to put 12x and 1x. And now I have to decide where I'm going to place them. So again, I can put the 12x right here. I could have put the 12x right there. In addition, because why do I know I could have placed it in either location is because 12 has a common factor of 3. 12 also has a common factor of 4. So it will work in either location. So I decided to put it in the lower right-hand corner. And then that means my 1x goes up here next to the 3. So now I have to go in and I've got to do the GCF and figure out what's the common factor. And I'm going to look at my line of 4x squared and 12x. And what do I have? I know that it is 4x. I'm looking for the greatest common factor. So 4x sits in both 4x squared and 12x. Therefore, I know I can place an x in the bottom rectangle because 4x times x is 4x squared. Now, I know that I can figure out my value right here because what do I multiply x by to get to 1x? Well, that is 1. So now I have 4x plus 1 is definitely one of my factors. And I could actually write that right here. 4x plus 1 is one of my factors. Now I have to figure out the other side. So I ask myself, what do I multiply 4 by to get to 12x? Or what is the greatest common factor between 3 and 12x? Well, that answer is 3. And I can verify that because 3 times 4x gives me 12x. So either way I do it is fine. So I know it's plus 3. So my second factor is x plus 3. And now I know that it equals 4x squared plus 13x plus 3. And I always like to go back in and verify it. How do I verify it? I use the FOIL method. FOIL method tells me I'm going to multiply 4x times x, which is 4x squared. And now I've got 1x, or 4x, times 3 is 12x, plus 1 more x is 13x. There it is right there. And then 1 times 3 is 3. So there, I know that it works. So again, moving on, I'm now going to do example C, which is another factoring example. So again, in example C, you notice that I've got 2x squared minus 5x minus 7. The very first thing I'm going to do is I'm going to notice that there is no common GCF between all of them. I'm also going to note in this one that I've got minus 5x and minus 7, which means I've got to pay close attention to my factors and making sure that I, grab the right positive and negatives. Take a look back at example B. Notice that I have positive, positive. And if you go way back to example A, again, positive, positive. So again, just making sure I make special note of what those values are. So when I go to multiply them and sum them together in my diamond, that I capture the right numbers. So again, I'm going to go to my trusty area rectangle. And I am going to write 2x squared in the lower left-hand corner. I'm going to pull my last term of 7 there. I'm going to go ahead and draw my diamond. And I'm going to multiply 2x squared and negative 7 together, which means I get negative 14x squared. And I'm going to pull my middle term right here of negative 5x, which means I'm looking for two values that are going to give me, they're going to summed to negative 5x, but when multiplied together, gives me negative 14x squared, which means I know what are my factors of 14. I've got 7 and 2 and 14 and 1. And when I look at 7 and 2, if I add those two together, I get 9. But I'm looking for a negative 5, which means I know that the negative needs to sit on the 7. So I know that my very first term is negative 7x, which therefore means my second term needs to be positive 2x. And I can verify negative 7x times 2x is negative 14x squared. And when I sum those together, negative 7x plus 2x, I get negative 5x. So now I need to go ahead and place both negative 7x and 2x inside my rectangle. Well, again, this time I'm going to carefully place, and I'm looking for GCFs and where I can place both of those terms. And I'm going to notice that I've already got a negative 7 in my rectangle, so I'm going to put a negative 7x in the upper left-hand corner, and I'm going to put positive 2x down in the lower right-hand corner. Now I'm going to go ahead and factor out the GCF of both of them, which means I know that 2x squared and 2x have a common factor of 2x, which therefore means I have an x in the bottom down here, because 2x times x is x squared. And now I'm going to factor out in the top right here. And I know I've got negative 7x, negative 7, which means I'm going to pull out a negative 7. So now all I have to do is figure out what is my very last term right there. Well, what do I multiply 2x by to get to 2x? It's positive 1. Therefore, I know my two factors are 2x minus 7 times x plus 1. And that is equal to 2x squared minus 5x minus 7. And I always verify to make sure that is indeed correct by using FOIL. 2x times x is 2x squared. And 2x times positive 1 is positive 2x. And then I've got minus 7x, which is negative 5x. And then negative 7 times positive 1 is negative 7. So it indeed works. The last example that I'm going to do is example D. And there is a couple of different ways to do example D. I'm going to go ahead and do it in a very straightforward manner. And then I'm going to show it where I factor out a negative number to make our lives a little easier. So here we go. So in example D, I've got negative 4x squared minus 8x plus 5. And the very first thing that I want to do is factor out a negative 1. And you're probably going, well, do I have to do that? You don't have to. However, you're going to find that it's a whole lot easier to deal with when I factor out that negative. We typically, mathematicians, don't like negative coefficients in our first term. Doable, yes. Easier when it's not there. So if I factor out a negative 1, you're going to notice that what I've got is 4x squared. That negative 8x becomes a positive 8x, and my last term becomes negative 5. And I can verify that by multiplying everything inside my parentheses by negative 1, and I'll get back to my original example D. So now I'm going to go ahead and continue to set up like I always do. This time, I'm going to make sure that I'm only using inside the parentheses. So I've got 4x squared minus 5 in my last terms. Go ahead and set up my diamond. I get negative 20x squared up on top. And my middle term is now positive 8x, which I'm looking for two factors, which I know are going to be 10x and 2x. However, I now need to make sure I put my signs in correctly, which means I've got negative 2x and positive 10x. So now, and I verify that by just making sure everything is aligned and correct when I multiply and add, which indeed it is. So now I'm going to go over and I'm going to fill in my rectangle. So I'm going to look at my numbers. I've got negative 5 and I've got 4x squared. Well, I know that I am going to put 10x here. And the reason why I'm going to do that is because negative 2x will work. However, it only works for the 4x squared. I cannot put negative 2x next to the 5 because there's no common factor. So I'm going to put negative 2x down here. So now I've got to go in and I've got to pull out GCFs. So what's the GCF between 10x and negative 5? Well, that answer is negative 5. And I'm going to take a look and make sure, because does negative 5 sit in both of them? Possibly. And I'm going to do the bottom. What is the value or the GCF between 4x squared and negative 2x? I'm going to actually pull out a negative 2x. So now I'm going to fill in the bottom down here. And what do I multiply negative 2x by to get to positive 2x squared? And that is negative 2x. And I can verify it up on top. Negative 2x times negative 5. Yeah, that comes out to be 10x. So now I'm going to put in my very last value down here. And what do I multiply negative 2 by? Negative 2x by to get to negative 2x. And that is 1. And again, I can verify by multiplying 1 times negative 5, and that should give me negative 5. And everything else works out within the rectangles. Therefore, I've got my two factors of negative 2x minus 5 times negative 2x plus 1. And I've got to remember that I pulled out that negative, so that goes back in front. So there is my factored form. So that was example D. And if I look at example D and I look at the way this is written, I kind of go, wow, there's a whole lot of negatives there. So I'm going to actually go back and I am going to show you without factoring out the negative 1 on the next slide. So look at the way I've set it up so far. Same exact thing, negative 4x squared in the lower left, 5 in the upper right. I've multiplied the two together, 4x squared times 5, I get negative 20x squared. Take a look. I had negative 20x squared at the very top of my other diamond. But look down here at the bottom. I have positive 8x for this example, for the first example I did for D, and now I have negative 8x. So now when I fill in my values, I have to be very careful to make sure that I pull the correct values. So again, take a look at what I've placed. I did negative 10x and positive 2x. And when I multiply those together, I do indeed get negative 20x squared. And down at the bottom, I get negative 8x. Let's take a look at the previous example. And notice that in this example, I had positive 10x and negative 2x. Again, those are the differences that I'm trying to point out to you. I'll continue to work the problem. You'll notice here that I went ahead and pulled out the GCF between negative 4x squared and 2x. Notice this time I decided to pull out a positive number. Same thing with negative 10x and 5. I pulled out the positive. And then when I went ahead and figured out my bottom values, I just kept in mind, what do I need to do in order to be able to get to negative 4x squared? And what did I need to multiply to get to 5 and positive 2x? So now my factors are 2x plus 5 times negative 2x plus 1. Do I end up at the exact same place? The answer is yes. So it's all a matter of how you want to do it. If you feel, I kind of like this method without pulling out the negative. But again, every time I do these problems, it depends on what I, quote, see first. So again, either method is fine. If I go back here, and if I actually distribute back this negative for everything, that means everything gets to be put back to normal, that I get 2x plus 5, and what else? I get negative 2x plus 1, which is the exact same thing I got earlier. So either way, I'm good. The textbook in example D shows pulling out the factor of negative 1 first. But again, I am good with either one because either way worked. I end up with the same exact thing at the very end. So those are all the examples from today's lesson. The rest of it were just monitoring progress examples, which you should always do as a way to get extra practice.